Hello and welcome back to another episode of Physics Partner. Imagine for a moment we could interview a baby who is still in the mother's womb. It's a cozy, dark and quiet world. We try to explain the outside world. Little one, there are giant metal birds called airplanes that fly across the sky and roaring trains that speed across the land, and we carry tiny glass slabs called computers in our pockets. The baby would probably laugh. It would think we have gone mad. For that baby, the only reality is a dark floating room. The idea of an airplane is not just strange, it's completely illogical. It makes no sense based on everything it has ever known. Now, here is the truth. You and I are a lot like the unborn baby. We live in the womb of the classical world, the world of baseballs, cars, and gravity. It's the only reality we directly experience. So, when quantum physics tells us that the tiny particles that make up everything have a secret double life, it sounds as absurd to us as an airplane sounds to the baby. But it's real. This is wave-particle duality. In simple terms, wave-particle duality means that every tiny bit of matter, like the electrons that power your phone or the photons of light hitting your eyes, can behave as both a particle and a wave. A particle is like a tiny solid marble with a specific location. A wave is like a ripple in a pond. It's spread out and can bend and interact with itself. Take light for example. Sometimes light acts like a stream of tiny bullet-like particles. This explains how solar panels work. Each particle of light knocks an electron loose, like a marble hitting another marble. But other times light acts like a wave. Shine a laser through two slits and it creates a beautiful pattern of stripes on the wall behind it. This is an interference pattern, something only waves can do, like water ripples merging together. The incredible conclusion: light is doing both. This brings us to a crucial point: the role of the observer. How we look at the quantum objects determine what they become. This is a lot like the story of the blind man and an elephant. One man touches the leg and says, "An elephant is like a tree trunk." Another touches the tail and insists, "An elephant is like a rope." Both are correct from their limited perspective, but both are also wrong in describing the whole, complete elephant. Similarly, when we set up an experiment to catch light as a particle, it behaves like one. When we set up an experiment to detect a wave, it behaves like a wave. We are only seeing one aspect of its true, complete nature. To sum it all up, here are main features of wave-particle duality. Number 1. Two faces, one object. Quantum entities are not either a particle or a wave. They are something more fundamental that manifest as one or the other depending on how we interact with them. Number 2. The role of the observer. The act of measurement forces the quantum object to choose which face to show us. We are an active part of the reality we are measuring. Number 3. It's a probable world. Because we measure it, a particle does not have a definite location. Instead, it exists as a wave of probability, a cloud of possible locations where it might be found. Our everyday experience is a poor guide for the quantum world. The universe is far stranger and far more wonderful than it appears. Embrace the weirdness. So I think it's enough for today. So thank you very much for listening and watching. I hope you enjoyed the video. I hope this video is useful for you. So take care of yourself and don't hesitate to write an email if you have any question, query, suggestion, and even classes are required. Take care of yourself meanwhile. See you in the next video. Goodbye.